Hello everyone, welcome back to the channel Coding Help. So in this video we are going to solve the problem of weekly contest 498, and there is two problem with the same name, smallest stable index 1 and 2. They have asked this will accept our brute force approach, and just we need to optimize it into the second problem. Right now let's try to understand the problem. What is stable index? Stable index means instability score is less than or equal to k. They have given k or num's length is n. If our instability score at ith index is less than equal to k, then we will return the ith index. Okay, so how we can find the instability at ith index? We need to take maximum number from 0 to I, then we need to reduce minimum number from I to n minus 1 element. Okay, that will be called our instability score. If our instability score is less than equal to k, we need to return that instability index. Okay, return the smallest stable index. Okay, if less than equal to k is there, then we need to return that smallest stable index. If no such index exists, return minus 1. Okay, wherever our first index is coming as a true for this condition, we need to return that index only. Now let's see with this example. We have given example 5014, then k is equal to 3. We need to find, let's take I as a 0. We need to find 0 to ith index maximum, 0 to 0, and minimum from 0 to 3. Okay, maximum will be 5 and minimum will be 0. So instability score, this one is greater than k. Okay, again we'll check for index 1. Maximum among this one 5 and minimum among this one is 0. Again we are getting 5. I is equal to 2. Maximum among this one, minimum and among this one 5 maximum and minimum is 1. This will give you 4, still greater than k. I is equal to 3. Maximum among this one will be 5 only. Minimum among this one, so this will give you 1 less than equal to k. This condition is true. We need to return 3. Right? We can see here. If no such index exists, we need to return the minus 1. Right? And write the code for this problem. Let's see the code. Let's try to understand the solution. What we need to take? We need to take minimum from right and maximum from left. Right? So we have taken maximum as a integer minimum value. Okay, and n is equal to nums of length. We are iterating from left to right. N minus 1 index. Now for I we have taken as a 0 index. From 0 to 0, 0 to I, we need to find the maximum. Here we are finding the maximum. Now from I to n minus 1, we need to find the minimum. So here we are finding the minimum value. If we are getting max value minus mean value less than equal to k, just we are returning that index. If we are not able to find that index, we are returning minus 1. Okay, now let's see the same problem with optimize approach. This problem is same as our previous problem. Okay, so we need to optimize the code. If you will run this problem using our previous code, so it will give you clearly. You can see the constraints, right? So how we can optimize? We have seen for every minimum element we are iterating from I to n minus 1, that is lead to n square time complexity. So what we have done, first we will compute minimum from right to left, as you can see here, and we have stored minimum into our minimum value array. Now from left we have taken maximum as terms of 0, okay, and we will continue computing maximum from the left hand side, and we will check our maximum value and minus minimum value is less than equal to k, then we will return I, okay, otherwise we will iterate. If we are not able to find, then we will return -1. Okay. Okay, thanks for watching. See you in the next video.